It's been 1 year since this block of the Commonwealth Avenue Mall between Mass Ave and Hereford Street began a major transformation. A tool known as an air spade was used initially to safely break up decades of compacted soil to help restore the health of this historic landscape. During the past 12 months, this slice of parkland has been fertilized, reseeded, watered, groomed, and fenced off to give it every chance to thrive. And as promised after our first report, we've returned to ask, how's the patient doing? For an answer, the Friends of the Public Garden turned to arborist Chuck Scherzy Jr. from Tree Specialists, Inc. in Holliston, Mass.
They wanted an independent study, so basically what I did was I drew a soil sample prior to the work being started. I drew a sample 4 months into the project being completed, and now I'm here today to draw the third and final sample.
Results will help determine the impact on the soil from what was done with the air spade. But to fully assess the health of an area, an arborist needs to perform a series of tests.
If you want to come up with an analogy, when you go to a doctor, he'll draw us a blood test. But overall, I mean, that's going to be part of the physical that you'll have later on. You just can't just base everything just on a blood test.
Scherzy is using Cornell University's Soil Health Assessment Guidelines to help him evaluate results.
Today we're going to talk about compaction and demonstrate that. We're going to look at aggregate stability, and we're also going to look at active carbon. A lot of this can be done in the field as well as in the lab, but I have some instruments and some other little tricks that we can be able to show exactly what has been happening here and being able to monitor it going forward.
What we're looking at is a soil compaction meter or tester, and what we're going to be doing is, as I'm pushing down on this, it's going to register on the scale. Going over 300, you can actually see where you're exceeding compaction levels that should be addressed. Pushing down, right now I'm over 300 at this point. I push down again, and now I'm probably into about maybe 475. You're looking at probably about 9 inches right there. So that level of compaction, it's a little much still, and that might be from what we've actually encountered with the marathon having been here. But I think again, it's still early. This was actually the worst side of the testing that I did initially when I came out. So what I would actually do is walk up and down the mall in arbitrary places, recording these on a piece of paper, and that would actually go out with all the data that I sent to Cornell, and they would use that to help derive the score that compaction would actually get. So in a lot of cases we're coming up into, where I'm hitting about 300 in that, I don't know, 8 to 9. Up here would be more like 12 inches, and that would be ample for what these trees actually need. This probe is telling me that what they actually did as far as the air spade, as well as the amendments that they put down and what's happened since then, is working. Okay, basically what we're going to do here is test for something called aggregate stability. And this device you see here, this cylinder hanging from the tripod, is actually a device called an infiltrometer. What it does is it helps to simulate rainfall, and it's going to fall on the sample that I have down here in the little tripod that is sitting in a 2mm sieve with filter paper below it. And what this does is it's actually going to take and help to test for the strength of the aggregates that are developing now on the ground with the work that was done. You can actually see where it's starting to wash away some of the soil, and it's actually leaving some of the aggregates behind. When you're done, you're looking at, in the filter paper, you can see what's left there. But basically, you're looking at the aggregates that remain. And it gives you a pretty good indicator of how well your management practices are going forward, whether it's going to be the type of compost that they used, how to the depth it was air spaded or tilled in. Also the management practices going forward here when they start looking at slice seeding, core aerating, among other things. That's actually going to help increase the microbiological activity in the soil, because they're byproducts of the thing that actually help with soil structure, and that's what we're looking for. The aggregate is actually the key to this whole test. Well, the thing that microbiology likes is carbon. They need a food source. They live on it, they feed on it. And what this test is going to do is basically take the soil that's in this tube, and we're going to actually add a very, very strong oxidizing agent. It's called potassium permanganate. Now basically what I have is I have a small little handheld spectrophotometer. Sounds rather involved, but it's not. It's rather inexpensive. And what that does is it measures wavelength of light. So we use the potassium permanganate is purple in color. So we take a standard sample with nothing in it, and we shoot a wavelength of light through it. It measures that. Then we actually take the permanganate and dump it in here with our sample, and what it does is that it will oxidize away the active carbon. And instead of being a deep purple, it lightens the color. Maybe not to our eye, but sensitive to the spectrophotometer, and give us another reading. That value then gets put into an equation, and then we can actually determine exactly how much active carbon is in our sample, or in this case in the soil.
This experiment could very well be useful to a lot of other parks groups and open green space groups. We're going to have results we'll be able to share.
Oh, absolutely. We're looking at not just so much the air spade, but we're looking at the physical attributes of the soil, the chemistry, and also the biology. We could actually use that not only for malls like this, but also smaller spaces, the backyard garden, commercial sites, among others.
To help deal with compaction going forward, Scherzy points to turf management. Besides irrigation and mowing, he emphasizes reseeding and aerating.
And also, I would actually suggest to the friends that they actually top dress this with compost each year, because I think that actually helps to work its way down into the ground, and also that active carbon keeps a lot of that microbiology really, really active. And they're really your engineers down there. They're the thing that's going to help keep this to a point where the compaction is at a minimum.
As we await analysis of all the data that's been gathered, Scherzy has a preliminary prognosis for his historic patient.
From what I've seen so far of the airspade work that was done, the way it was done, the products that were used, I think that the area here on this block is standing tall right now, and will be going forward in the next say 4 or 5 years anyway. But that's given the actual maintenance practices that are done on top of the ground with the turf. As long as those are followed, then I think that they'll keep the compaction, which is really the chief thing they have to keep after, to a minimum. And I think you'll continue to have a nice catch of turf. The trees will thrive, and then with that knowledge in hand, then they can move on to whatever the next project is going to be.
A final report on these tests is expected soon, and will help spread the word when the information becomes available. This ongoing project is made possible by the fundraising work of the Commonwealth Avenue Mall Committee, a joint effort of the Friends of the Public Garden and the Neighborhood Association of the Back Bay. With cooperation from Boston Parks and Recreation, they hope to learn how to improve the growing environment in urban green spaces like this one.